There are several different types of reactions that we need to explore. So the first one that I'm going to talk about is that of a combination reaction. This kind of sounds like what it is. And that is that you're taking two things, like whatever A and B could be, and making like AB. So here I give an example of when you have silicon and oxygen gas would give you SiO2. Or like another example of that might be if you have Na and Cl2 that's a gas, when you combine those two things, they're going to make salt. So NaCl, like that. Okay? So that's the first type of reaction. The next type is called decomposition. So if you're combining things in a combination reaction, a decomposition decomposes them. So in other words, you have something that's already put together and it separates out. So you can have something like hydrogen peroxide here that decomposes into water and that also leaves off an oxygen. So you could have it as that O, or we could see that instead as like an O2. So if you wanted to write this instead as O2, depending on what the reaction is, that might be something that we can see there as a decomposition reaction. Next comes what's known as a single displacement reaction. And this is very much like what it sounds like as well. We could have one thing like C reacting with D and E, where C kind of kicks out E, and instead you get C and D and E. So we can see here, like if you have lead, which is Pb, and you react that with CaCl2, what ends up happening is the lead can displace that calcium. So you end up with PbCl2, and the calcium goes away, or sort of like goes off on its own. So that is a single displacement. One thing is displaced. That is different from a double displacement reaction where two things are reacting with each other and they're kind of like swapping. So there's lots of dances like this, for example. In this case, what's happening is that C is combining with F and D is combining with E. So that the two different portions kind of come apart and recombine with the other thing, okay? So this would be like C and F and E and D would be your products here. Okay. We'll look at that in a little bit too. The next type of reaction is a combustion reaction. So combustion is doing much of what you know combustions do. Combustion engine is what most gas-powered automobiles are running on. So if you have any type of carbon-containing compound and you combine that with O2 gas, the products are CO2, H2O, and heat. So that heat can also be seen as energy. If you look at somebody's car as they're ahead of you and it's a cold morning, then you'll sometimes see some water coming out of their muffler. That water is this H2O right here. So this is taking place in your gas grill. Propane is C3H8. You can combine that with oxygen gas. You get CO2, water, as well as that heat. That heat's what's cooking your food. Okay. The most difficult one for most people to see is what's known as an oxidation reduction reaction. And I tend to separate this into an oxidation phase and a reduction phase, sort of like what's happening on the oxidation side, what's happening on the reduction side. So oxidation is a loss of electrons by definition. Reduction is the opposite. It's a gain of electrons. So sometimes we have to separate this out. So if we think of lead, let's say we start with lead, and we end up in the end of that reaction with lead that has a +2 charge. That means that we end up with those 2 electrons. So what that says is that initially this Pb had those 2 electrons and it gets rid of them. We lose those 2 electrons because Pb no longer has those 2 electrons. Okay. On the other hand, if we have Cl2, Cl2 is currently charge of 0. Both of these are charge of 0, by the way. Why? Because it doesn't say that there's a charge. That's why. And if at the other side of the reaction, you would have 2Cl minus, you have to gain electrons in that process. And that's what's known as a reduction. There's a way to say this or help remember this. I see this as Leo the lion goes grrr. Okay, so here's what that means. A loss of electrons is oxidation. There's your Leo. Loss, electrons, oxidation. And a gain of electrons is reduction. So what things look like when you combine everything is this. So keep in mind in this process, Pb on the other side is going to Pb plus 2. And we have Cl2 that's going to 2Cl minus. So let's say that that's what you're starting with and you don't know where the electrons go. It's very much like what we've looked at other things. If we have a +2 right here, we have to balance that charge out. So that means there's 2 electrons on this side. And if we end up with a negative charge on this side, then we had to add the 2 electrons on this side. And that's how I got that. Okay? These you probably need to practice a little bit. But at the same time, this is stuff we're going to also revisit in 1152. And you don't need to know it in extreme detail. Just know that these things happen. That's it. We could have different number of electrons that get exchanged. Okay. Other things that we can put into a balanced reaction to make things more notable, like to tell more details about what's going on. We can put in the state of matter. If you have an S, that means solid, L is liquid, G is gas, and sometimes you see one that's just AQ. And all that means is that you've got something that's dissolved in water. You may also see this heat, like delta or just a triangle that's pointed up. That is coming as heat. And as a matter of fact, that actually is coming many years ago, was used as a symbol of fire. So that's sort of what that's symbolizing there is that you've got a little bit of fire there if you've seen a symbol that's similar to that. Kind of cool. Okay. Next, we need to look at how to balance chemical equations. Now, this is something that hopefully you have seen before. So the first thing I want to make sure that everybody knows, we have already made formulas. Remember, formulas are based on what the charge is of things, or it's a given by the name, like sulfur hexafluoride. Formulas are balanced in order to get your ionic compounds. So like remember, if you have, let's say, Hg plus 2 combining with Cl minus, that would mean that your balanced equation is HgCl2. So, or your balanced formula is HgCl2. That formula is put together already. It's done. That's how you put a formula together. Once you put a formula together, you cannot touch that anymore. So don't mess with that anymore. It's done. Matter can't be created or destroyed, though. So whatever you're putting into a chemical reaction on the left side must be the same thing on the right side. So when we go to balance, we use coefficients, and coefficients are things that go in front of formulas. So for example, if we have H2O2, and we're going to make H2O and O2. Now here's the thing. We can't change that reaction. You can't say that with H2O2 you're going to get H2O and just an oxygen that floats out into space, because oxygen doesn't usually exist by itself, at least not for long. So we need to find a way to balance this reaction, and we do so, and here's how, okay? So I would say, okay, well, if I have H2O, and I don't have this yet, so don't worry about that yet, okay? That tells me I have 2 hydrogen and 2 oxygen. On the right-hand side of that equation, I will have 3 oxygen and 2 hydrogen. Well, that's not balanced. So we need to do something to make it balanced. So I start by putting a 2, and I'm going to start with the left-hand side, and that's the reason why I put that 2 there, okay? If I do that, then I need to say, okay, 2 is in front of all of this. So I get how many of each I have, because I'm going to multiply this 2 by this little number 2, and that's how many hydrogen I have. So I have 4 hydrogen. That's where that comes from. Then with oxygen, again, I have 2 times 2. That's 4 oxygen. Okay. Well, on the right-hand side, what I need to do again is I need to use that 2 in front of the H2O, because 2 times 2 hydrogen is going to give me 4 hydrogen. And then I have 2 oxygen here, and I have 2 oxygen here. So that gives me a total of 4 oxygen. So if that means that we've got the same number of oxygen on both sides and the same number of hydrogen on both sides, then it's balanced. So something I didn't state that I shouldn't have taken for granted that you know is this arrow. What that means is that over here we have reactants, and over here we have products. Our arrows are kind of like equal signs in math. And what that means is that the starting material has to be the same as the products. Now, we did talk about that when we talked about nuclear reactions, right? Okay, you probably need to practice this. So there's lots of examples that are given on the worksheet that is in the worksheet folder. And I'm pretty sure that the answers are also in the same folder. So please go and check that out. So please spend some time looking over that and let me know if you have any questions. Thank you.